Hypothalamus Artificial Intelligence, HY, is a knowledge-intensive company in advanced and complex mathematical modeling. Its main research focuses on the integration of traditional artificial intelligence, mainly supported by artificial neural nets, ANN, and the machine learning algorithms, based on support vector machines, SVM, with the large-scale mathematical programming principles. This is aimed at producing artificial brains, that is digital transformation driven by autonomous and intelligent algorithms in real time, in accordance with the era of Industry 4.0. The intellectual property of hypothalamus artificial intelligence is supported by our methodologies and technologies that has been used for 50 years developing and implementing highly complex mathematical model and decision-making systems at enterprise scale. HY has developed a robust library of successful algorithms for application development and use cases across large multi-regional enterprises. 80% of our process of computation systems generation is executed by AI agents, which ensures approach and implementation, at least 1,000 times faster than an army of programmers, for high complex mathematical applications. Our solution is universal, it is standardized, and it is easy to adapt and implement, satisfying the demands of fast digital transformation. Our methodology is based on artificial hypothalamus framework, and the use real-time autonomous distributed optimization, allowing algorithms to evolve, generating self-learning processes, minimizing human intervention, and our solution produce an average 10 to 15% reduction in operating cost. The guarantee of our growth, and the quality of the knowledge we produce, is supported by our areas of research, technological development and innovation. These are artificial brains, large-scale parallel optimization algorithms, and optex, the artificial intelligence that make artificial intelligences. As a result, our intellectual property helps produce highly complex mathematical models for end users. HY was created in 2021 and began formal operations at the end of 2022. Its founder and chief scientific officer is Ang. Jesus Velasquez Bermudez, Ph.D., who at the age of 21 made for Federal in Colombia, his first professional job as a mathematical modeler. At the age of 22 he obtained his master's degree, working on a stochastic optimization model, and in 1978 he created, in Caracas, his first company, where he was the leader of mathematical modeling. In 1990 he created Decisionware Ultima, in Colombia. HY is a spin-off company of DW, conceived during the COVID-19 pandemic. Ang. Velasquez Bermudez's professional life is divided into three main stages: growth until 1990, maturation until 2015, and acceleration since 2016. He obtained his Ph.D. in 2006, at the National University of Colombia, Campus Medellín. Artificial brains. This is the biggest challenge taken on by HY. It's the result of its 50 years of work in highly complex mathematical modeling. As George Bernard Shaw would say, imagination is the beginning of creation. You imagine what you desire, you will what you imagine, and at last you create what you will. Framework. HY is the creator of the concept of artificial entrepreneurial brains, which is supported by the development of parallel thinking, when a complex system must be analyzed. The artificial brains corresponds to the scientific foundations, more specifically mathematical fundamentals, that allow to connect multiple mathematical models, algorithms or robots, exchanging information between them to obtain a common goal, and act as holistic intelligence of the organizations, or parts therein. Like the human brain, the artificial brain is composed of the following artificial components: neocortex, hypothalamus, and hippocampus. This evolution may be summarized as the shift from artificial intelligence to augmented artificial intelligence. The artificial brains is the evolution of DSS under the Industry 4.0 revolution that is conceptualized as a set of mathematical models that exchange autonomously information between them, working online, using distributed optimization. When all the models that make up a company are solved using the concepts of real-time distributed optimization, an artificial hypothalamus is obtained. This is how the human brain faces reality, using multiple models of reality, acting permanently in parallel, to make decisions. The algorithm that simulates the hypothalamus is assembled by Optex, the HY's cognitive robot, using the models that traditionally make up a decision support system. The current state involves the integration of edge computing and cloud computing to implement highly complex mathematical models. Starting from the perceptron, the first artificial neuron created, the knowledge of neuronal modeling has evolved, currently having multiple types of artificial neural nets. This new type of neuron will be called mathematical artificial neuron. Its name was derived from the fact that the neuron is built based on mathematical models that represent a system, and that it does contains logical or intuitive elements. Two mathematical artificial neurons communicate with each other, forming a network of mathematical artificial neurons. Communication occurs in two directions between the two neurons. The communication protocol between the two neurons is defined by mathematical laws developed to solve atomized problems. The modeler can choose the protocol, but not the communication process, which for optimization is based on the scientific laws of duality theory. A large-scale system can be represented by a mathematical artificial neuron, and covers multiple subsystems, where each of them can be represented by a mathematical artificial neuron. An artificial hypothalamus is a network of mathematical artificial neurons. Each of them represents a system or subsystem. Any type of organization can be represented following these principles. The case of a poultry production system is presented. The system has been divided into 6 subsystems, which together make up the poultry production system. To connect multiple algorithms, today may be hundreds of thousands, but soon, of course trillions, it is necessary to develop a universal mathematical language for algorithms. The principles of this language, of mathematical origin, be based on. Algebra is the intellectual instrument which has been created for rendering clear the quantitative aspects of the world. The importance of the Alfred North Whitehead's phrase lies in the fact that, all modern mathematics is based on algebraic models, that become algorithms, that use all the power of current computer technologies. Math is a natural standard for all professionals who need simulate processes, of any kind. The formulation of a problem in algebraic terms, or in differential equations, allows professionals, from different cultures, and with different idioms, to express their mathematical models, in such a way that they are understood by professionals with mastery on industrial algebra. Two algebraic formulations of the same problem can look different by the symbols used by the math modelers, but, if we build a map of the symbols, and write the equations to their reduced form, all formulations should be equal. On the other hand, Joseph Louis Lagrange was an Italian mathematician. In mathematical optimization, the method of Lagrange multipliers is a strategy for finding the local maxima, or minima of a function subject to equality constraints. Here resides the foundations of constrained optimization and duality theory. That's the basis of a mathematical language for robots. So, the artificial hypothalamus, a part of the artificial brain, is the algorithm that control the workflow of the models of the decision support system. It includes the constraints that guarantees that the system is in the optimal path. This is based on the duality theory. Starting in 1978, the HY's intellectual property, HY IP, began to accumulate knowledge about large-scale parallel optimization algorithms, to accelerate the solution of highly complex mathematical problems. At the time, the founder of HY was involved in a Venezuelan company, PDC Ingeniería, which invested $500,000 in a ModComp Classic computer with 1 MB of RAM, some cache memory, and 10 MB of hard drive. To be able to implement large models, in such a small computational environment, it was necessary to learn methodologies such as Bender's partition, and Lagrangian relaxation. Not to do parallel computing, but to be able to solve real problems in such a small memory. HY IP appropriated the knowledge of the duality theory, as the basis for solving problems based on their atomization. It was like a company in Silicon Valley, but in Caracas. Their economic future was not guaranteed. These algorithms accelerate large-scale math problem solving by partitioning and decomposition of complex systems, atomization, and the integration of physical models of differential equations with large measurement systems. Parallel optimization algorithms, to accelerate the solution of large-scale mathematical problems, by partitioning and decomposing complex systems, that are part of the HYPOTHALAMUS. Multi-state Kalman filter, MSKF. Generalized dual dynamic programming, GDDP. Nonlinear dual dynamic programming, NLDDP. Primal dual surrogate algorithm, PDS, and multi-Benders decomposition, MBD. They are included as standard methodologies managed by OpTex, Optimization Expert System. OpTex is an expert system focused on the design, implementation, startup, and maintenance of high-complexity mathematical programming. Expert system in the sense of artificial intelligence. OpTex was born from a paradigm change in the traditional form to make mathematical models. The traditional process implies that making a model implies making programs, which becomes the most expensive activity of the whole process. The paradigm shift was very successful in 1991, when OpTex was born as an optimization technology of decision-ware limited, DW. The new paradigm consisted of parameterizing the model into a relational information system for optimization, and creating an intelligent tool that, based on the contents of the database, generated all the computer programs for the model to work smoothly. The level of abstraction of the information system data model was such that in practice, all DW mathematical models were performed using OpTex, Optimization Expert System. Over time, the database became a repository of models, which can be managed by simply clicking, allowing to dynamically join, split, or adjust the models, to extent that new models, or new versions of existing ones, require, making mathematical models like a Lego model. Despite OpTex technical success, its commercial success as a commercial optimization technology was not a success. But the facts show that many AI researchers are trying to solve the problem of making automatic programs without errors, a test already passed by HI in the real world. OpTex is the tool that emerged from Praxis, that organizes all concepts of artificial brains. This is fortunate for HI, which gives it a many-year head start, on the road to creating perfect mathematical models with artificial intelligence. OpTex is the HI's artificial intelligence that makes artificial intelligences. OpTex, Optimization Expert System, is an optimization technology aimed at producing artificial hypothalamus, as the technological and logical evolution of the current decision support systems, SSDs, moved by humans, to SSDs 4.0 moved by robots.
The goal of OpTex is the best way to make software is to have and to do it. The HI approach is aimed to develop mathematical models using cognitive robots, that eliminates the tasks of computer programming, since the robots takes care of this process. This enhancement the mathematical modeling capacity of the professionals and produce error-free code.
Making very large-scale models by the traditional way, using a computer programmer, it is an impossible way, because the programmer only can write a limited number of lines, of good source code per period. Maintaining these models can be more complicated than doing them, if more than one programmer intervenes in the process. OpTex can produce infinite lines, of perfect source code per period. OpTex are oriented to state-of-the-art decision support systems, DSS, that integrate state-of-the-art technologies of advanced analytics and optimization, like mathematical programming, advanced probabilistic, machine learning, and artificial neural nets.
OpTex generates the large-scale algorithms required by the artificial hypothalamus.
Highly complex mathematical models for end users.
HI uses OpTex to implement all its end-user mathematical modeling applications. HYPOTHALAMUS is a collection of specialized algorithms for optimize the value chain.
An example of the solutions offered is HI-Power, a decision support system for agents in the electricity and gas sector. Another example is Oil and Gas Artificial Brain, which covers the entire oil supply chain. The solutions cover multiple economic and industrial sectors. On YouTube and LinkedIn you can obtain the videos related with mathematical models to end users, and the technical documentation about them. The new way of mathematics is directly related to the parallel thinking, and today it can be said that like paper-based math, sequential mathematics for single processor computers, will be in the short term a dead language. As in the human brain, in the future only parallel mathematical thinking will be practical. The new analytics is autonomous, parallel, and distributed. Thank you for your attention.